So what I would suggest, maybe I'll suggest this tomorrow, is for them to take a photograph of the game board. If your game takes more than an hour's play, take a photograph every 20 minutes as you play. So if you need to go back to the game as well. I can also talk about whether they have a Markov game. Yep, you guys have done Markov games? You can do that in that. So, but they won't know what that is yet. But I can use the term a Markov chain. And they will everything you need to know about the board game and encode in the current visual state of the board game. Are there other things that are going on? So I think we're interfering with this. Yes.
Let's get back to the
okay, so back to the cloud.
strand of thought. Yes.
Apparently I've created
Thank you.
a way to stream.
Yes, thank you very much.
Yay.
Thank you. So my setup, I stay here for the next week, so just ensure it will work when I'm starting my next lecture next week. Cool. So who actually did the regular expression right now and who just chatted with the neighbors? Right, who did the regular expression? You? No? Yes, Jonas? No?
Me and Jona had
Okay.
a small conversation.
All right, but it stopped halfway through. So okay, let's continue with the next thing then. Apparently you know how to use your time productively, so we do it another time. Cool. So streaming works, and we are good to go. So today we're talking about webhooks. Are you guys familiar with webhooks from another course? Point is, this course is kind of hit and miss a bit, right? Because we generally always introduce some new technology that you may or may not have heard before. And so it's always good for us to gauge, well, you know, that's not something I really need to know about because they do already. So some feedback. Did anyone, or rather, does everyone know what webhooks are about? No? Cool. Sweet. Who has experience with webhooks in some way or another? Yeah, you use them? For what? For bit, yeah. Cool, nice. Okay. Anyone else? I heard some. Yep. Plex. Okay. Was it the media? Media center, right? So. Okay. Cool. Anyone else? No. Cool. Yeah. So we need to deal with them, and you guys probably have dealt with them, but you're probably not 100%. You know, it's not really explicit to you what you did with them. Does anyone want to explain the intuition that underlie webhooks, especially the ones that have experience with it? What are they about? Okay. So, in your concrete example, how did that work? Yeah. Okay, cool. So just to relay the conversation here, so the idea of here in the example of webhooks here in the context of Plex, which is a media studio, the idea was that a webhook is kind of triggered or invoked, if you like, once a particular, in this case, media file has been played or something like that, right? So some sort of, well, the key thing there seems to be we have some sort of event, right? Cool. That's probably quite similar there. So well, we had some comment over there regarding GitHub commits, right? Commits to a repository, and then suddenly something is triggered. So that's the key idea there. So how is that different from other patterns of interaction that we know? Do we know? I mean, what did we do up to now? How do we still have interaction, right? You guys were talking about communication somehow, right? Different services communicate. Yep.
We're using get to ask to receive information, using post to ask to submit information.
Yeah.
We haven't had like triggers happen whenever we do.
Right. Cool. So you mentioned one keyword there.
Trigger.
Trigger. Yeah. Exactly. So generally we have more like a the servers here. client is here. We generally have the kind of a initiation by the client, so it's the first and the request, and then a corresponding response. And what is that usually called? I mean, if you were to implement here, sorry for that. Let me turn the whiteboard. No, once. So, what is that process or this interaction pattern generally called? What do we call that?
Request response or
Yep.
client server.
Yep, I know what you mean. Yep, but like you probably know that from your web service, from your. I had this experience just very now. So replugging your machine from a wireless network to a wired network, and suddenly your website is gone, right? You frantically press F5, right? So that's the kind of way of recovering or identifying whether you actually got web connectivity or not. And the idea, the concept here is called polling, right? So yeah, polling. So that's the pattern, the polling pattern. And this is what we have used up to now, right? For all our web services, basically we invoke something, right? You guys invoked GitHub, for example, and you get something response or not, and do something with it, right? So you guys were the client, and you were the server for us. We were our evaluation system was invoking your service, and you did the same pattern with someone else. Cool. So webhooks, how are they different here? For the ones that have experience, or anyone else used the term trigger there? That's why. How are they different? Yep.
Well, the polling pattern, we invoke the server, because in Webhook you have a listener of that server, which automatically triggers when something happens.
Right.
So we, as a human, don't trigger the server, but it's a process.
Right. Exactly. So what's the advantage, or is there an advantage?
The advantage is that it happens automatically,
Yeah.
because you don't have to worry about it or refresh it.
Automation. Okay. Well, but I could automate polling as well, right? Why do we still think that this trigger approach is the preferable one? What are possible problems? Yep.
You don't need to continuously ask for something. You
Yes.
can just wait for the response itself.
Yeah. So it's less load on anything really, right? So both on the machine, you actually don't need to implement some sort of polling mechanism or some timer on your part. Let the server do that, not the client bit. And obviously, network transmission is a particular aspect. And what other aspects? You actually experienced that firsthand in your first assignment. What other problems can occur by using polling?
You can run into a request limit.
Exactly, right? So you run it in some sort of resource use limitations. So, and if they're not clearly specified, then you can't actually adjust your polling according to it. But you could, but it's kind of a weird approach of approximating the server's limitations regarding polling. So it's not necessarily the preferred approach. Instead, let the server decide when to actually send a response, right? So the idea is here that actually the server more or less is the initiator. So let me create a pattern that roughly looks comparable. And yeah, basically that's basically it. Well, kind of. So what's the prerequisite for that to work actually?
You must have something changing for the trigger to, trigger. Or
Yeah. So you have you have something happening here. Yep, that's cool. But yep.
client has to be listening for
The client? Yes, the client needs to be kind of a server in itself, right? At least it needs to have an open socket that listens to responses or requests from the server. Yeah, whatever you call those at this stage. Yep, cool. What else? What is the prerequisite for that actually to work? Or put it differently, in this scenario, did the server need to know about your client?
no.
No, right? You just you look up the API, you figure out the URLs, and then you get the report information that you need to solve your problem, right? So quite straightforward, right? How's it in this case?
The server needs to know where to send a response.
Right? So we need to have some sort of indicator, at least principle, at least an IP address to know what the client, who the client actually is, right? So you need to have a publicly addressable unique identifier on the client side, and you actually need to send that to the server in the first place. So I make that 0 here because it doesn't really correspond to a proper transaction, because you do that once and then you get repeated requests from the server, or notifications by the server subsequently. Yeah. So you need to tell the server what the client is, what the client's address is rather, and then the server will, notify the client upon or trigger a connection when certain events happen. So what's the schema called? What would we call that schema? Yep.
Subscribe.
Yep.
Publish. Subscribe.
Yeah. Exactly. So that's the publish subscribe pattern, where potentially interested parties, here in our case the web service clients here, so you guys see what's going on, actually subscribes to the server in the first place at some stage, but only once, or potentially deregisters. So you have kind of a control management interaction, if you like, and then the content payload related interaction by the server. So you're based on an event, your client is actually invoked and notified. And that is pretty much what webhooks are about. Yeah, so it's the idea of inverting the relationship, not having a classical server-client relationship where you invoke a server, a known server, but actually tell the server who the client is and develop a reliable, seemingly reliable relationship there. So, and one informal way of characterizing them is to say it's kind of a user-defined HTTP callback, because in the context of webhooks, I mean, you could conceive other mechanisms of implementing a publish subscribe scheme, but in the context of webhooks, the idea is really that we use web technologies exclusively. So again, one of those standards-based, generally using a REST API, but not necessarily. You can, roll your own if you like, but generally using a REST API where we have those fixed method sets that we can use, and web-based encoding mechanisms. So generally, the request would either be JSON encoded, right? So we could be reasonably efficient and open. So it's quite straightforward. Again, like we did before, scraping basically an API and just inject it into the webhook as a payload. And you wouldn't send it as a post using a post method, for example. Or the other form is using actual form encoding. So again, those HTML forms that they're using, they basically have associative keys that point to the values, so we can use that as payload as well. So you can basically direct the form, for example, towards a given service. So there's different ways of encoding that are supported, but JSON is probably the more common one. So generally, the key things that you need to know about, especially you if you're implementing them, and hopefully you will do that to some extent, is the idea of having an event. You need to know when a particular trigger is actually to be invoked, right? So, for example, in the case of a GitHub repository, what could be potential triggers? There was one example there. Yep.
Clone.
Yep. Clone would be one. Yep. Whatever. Yep.
Commits, pull requests.
Anything, right? So literally, exactly. So anything that is actually happening on that particular platform, and you could potentially hook into, that's where the term comes from, is basically the idea of having a hook, but using web technologies, therefore webhook, and that allows us to interact across web applications. And it can be literally anything, posting, committing something, cloning something, creating a branch, writing to the wiki, launching an issue, closing an issue. I mean, any of those possible events. So that's the trigger. And we obviously need to URL to the hook. So that's the telling the server that's what you need to invoke. And we obviously need to have a payload specification. And that's where things get murky again, because it strongly depends on the services that you're dealing with, because they again have a pre-specified payload format that you need to adhere to in order to interact with them. So those are the key things. That's actually quite straightforward approach. The technology is quite simple, but extremely powerful right now, and that's something we definitely need to play with if you want to have integrated services. So, I mean, like you said, it's pretty much useful in any case where we have some service that triggers something or needs to trigger something asynchronously. So, where you basically need to register and await a particular event. And it's commonly used in the area of continuous integration, that is having a pipeline of or kind of a workflow of deployment from your code repository towards the actual production environment. So it includes automating testing up on new commits, see if the test actually passes. If the test passes, actually put it in the staging environment, see if it properly launches, and incrementally possibly move it into a production environment. So having a continuous approach that is largely automated. Particular testing is the key here. Automation of testing indicates whether a particular step has been passed and allows the basically deployment in production environment. But we talk probably more about a continuous integration at a later stage to some extent. It's actually more related already to the infrastructure as code course, I guess, because it's central to deployment, but I think we need to know something about it because there have been extensive developments in the past few years. Another use case is API services. So there is an entire, you guys may have heard about some of them, there's an entire new business model where the idea is that you actually build APIs and your client basically asks for particular types of integrations, you build those integrations, expose them as an API, and you charge per use. So it's actually a quite neat business model. So meaning your client has different systems, wants to integrate them or use an external system, for example, but it's not sure, doesn't want to invest time in integrating them explicitly. So you can make that your service, expose it as a third party, and charge users for using it. And there's kind of a bit of a market that has developed around this idea to allow, so basically you're just an integration provider based on web technologies, which is kind of a neat idea. And again, somewhat related to continuous integration, but in a more comprehensive manner. It's not so much only code or software development, but rather any sort of enterprise service that you can think of, accounting systems, material management, things like that, possibly. So implicitly, as I mentioned before, it's particularly used in the area of issue tracking or ticketing as well. Project management is related to Trello, for example, has support for that one as well. Tickers, as used in training platforms or anything where thresholds are monitored, in particular temperature sensors and stuff like that. So it may be relevant again for your assignment. And the last aspect being, again, service monitoring is quite common there to deal with webhooks nowadays, even though there can be some challenges here and there. All right. Cool. So one of the key things, I think we explored that already, between the key difference between API and webhooks is really that the API generally relies on a polling pattern, right? So you guys invoke something and you hit rate limits, get timeouts, connection problems, whatever else, and you actually need to encode all the error handling yourself, right? For example, you're actually invoking GitHub and you get either a timeout or you're hitting a rate limit. You need to identify in your own code which one of the two it was, right? So it can be quite kind of tedious and very specific to the problem you're dealing with. So it's not a very generic solution available for that one. So you have heaps of error checking to deal with possible timeouts, because only based on, for example, one situation where you couldn't pull, for example, from the GitHub API, you wouldn't want to conclude that they are offline or something is wrong. It could just be that there's a timeout somewhere right now in your routing infrastructure or whatever else. So you would need to deal with all those problems. And in webhooks, it's quite the other way around. It's basically you just wait, and hopefully you will be invoked. That's the key idea. Cool. What are the problems with webhooks, though? Are there any problems you could imagine? Yeah.
The server isn't like it isn't stateless anymore. It has to know about you. It doesn't track, so you have to maintain that the data is correct on the server side.
Yeah. Cool.
Which is a step away from like the rest of stateless servers.
Well, we can use REST as stateless solutions, but the idea about is, yeah, no, you're right. I mean, it's really about resource management, but you don't need to maintain the state of the client. That's right. Yes. So yeah, in that respect, it's quite different. Yes, definitely. I mean, there's no way you won't be able to do it in short without database, right? So you need to have something like that. Cool. Yep. What are the issues possibly? Again, how is the interaction working? Okay, yeah, very good point. Yep. So you may actually introduce load issues on the server, which is or new load issues on the server, where you have an excessive extent of registration of webhooks. Very good point. Yes. So you actually need to deal with that on the server side as well. Yes. So what's okay? Let's looking at this issue. What's the one way of mitigating this issue? Right. So so basically, just to relay that to a wider crowd, it's basically kind of a learning element in there, right? So or monitoring. The server actually triggers whenever server triggers your webhook and you don't respond, or send an invalid response code, or you know, constantly timeout will basically be removed. Yep, that's one possible way. Yep.
You can also have an expiration timer on
Yep.
the subscriptions.
Very nice.
Resubscribe with intervals, so you make sure that all subscriptions are vanished.
Yep. Cool. That's a good point. You could have an expiry-based approach, but ideally you want to attach that or connect it associated with some sort of reminder for the user, right? Because you don't want to have an enterprise service suddenly disappear because you have an expiration on your webhook. Yes, but the idea is very good. Yes, cool. What's another more architectural problem we need to think about there though? Then, if we deal with a large number of webhooks.
It takes time to update or go through and check them all. Whenever you get a request, you have to check, okay, so was this something that any of these clients asked to be updated about?
Yeah, cool. Yep. So
I don't know if that would be a problem when it scales.
yep. So exactly. So what any particular ideas how we could deal with that from an architectural point of view? It's moving a bit into infrastructure, but just to think about it. Yep. So we have the database, right? So and this database maintains all possible webhooks here, right? How could we make this operation as scalable as possible? Especially if we're dealing with a large number of clients with different requirements and different triggers and all that kind of stuff. Which in GitHub probably has that issue. There's one concept that we learned about already to some extent, and again it was about asynchronicity, something like that. So yes, asynchronous invocation. So the idea is that you don't really just iterate like in a large loop through all the different webhooks and invoke them one by one, but actually you spawn workers that deal with that issue, and those workers basically take entries directly from the database and basically work those off. You know, so basically you don't have that timeout issue, just parallelizing the operation in itself. And if this guy takes ages because the recipient times out, doesn't matter. Those one will run in parallel and still work and operate. So there's ways you can deal with this by separating the state or the database, if you like, from the actual operation. So you have worker threads that you spawn off and run it. Yeah, as opposed to having a big giant loop where you iterate through the database and you don't need to check for all potential triggers, invoke their actual URLs and hope for a good response. Because else, if there's timeout happening, you obviously any subsequent invocation needs to wait. If you think, for example, about the trading platform, which is I think a reasonable example, suddenly the trade performance of your potential client who registers a webhook with you may depend on his order of registration with your system, right? So or the order in which it is actually stored in your database. Whereas if you parallelize the invocation and notifications to the client, you probably won't have that issue, at least from a perceptible perspective, right? So something also we need to think about in how far does my design affect real life, right? So does it still represent what I actually want to represent in real life, meaning an ad hoc notification of everyone at the same time? So, but this is one way you can work around it. I'm very certain that GitHub has a similar infrastructure to precisely do that. but it's something to bear in mind. That's very right. What are the mechanisms that we have in Go to work with asynchronous invocations or anything asynchronous in first case? Go routines, right? So it would be a classical example for Go routine where we basically initiate some and they basically feed directly off the database and invoke target services. So that's the key idea there. Cool. So that was the performance thing. But I want to get into some other aspects that can be kind of problematic with webhooks, or aspects that are of concern. The guys that actually work with webhooks, how do they look like?
What do they look like?
Yeah, how do they look like? Webhooks, yes. Well, particularly URLs.
Oh.
Because that's the linking pin, right, between client and server. Is basically the URL that the client registers with the server. No? Cool. Right, let's explore it briefly. So let's see if we can deal with this. So I'll just to showcase the idea here. So I set up a Slack channel. You guys know Slack, right? So it's something what you would call the predecessor to Discord or something like that. But no, it's quite commonly used. Oftentimes, particularly in software development teams, or it's kind of openly used. It's increasingly accessible to any kind of project management-y environment. So it's basically allows you to do instant messaging, working on channels, particularly private channels, public channels, direct messaging. All those features are basically there, and generally has a general channel and a random channel and some other ones. You can invite people, and this one is set up. By the way, the name is ntnu-cloud, as you see in the URL. .slack.com. Anyone with an NTNU address can sign up to that team and play around with this. So you later have the opportunity to do that as well. So you can actually use that channel. Please don't use it because it's kind of possible as well. So let's look how we can actually integrate it. And Slack is particularly known for that particular purpose and quite similar to Discord, but I want to show it in Slack so you actually explore something else on your own, but you have kind of an idea of how it works here. So in Slack you have so-called apps. And there are various apps for different purposes. Apparently one even for the Google Drive integration, which I didn't set up. But you can actually come up, introduce what they call custom integrations. And if you type something like webhook, I think they have an app for that one, yes. So we want to have incoming webhooks because we want to have a notification in Slack. So you just add a configuration, as it's called, and you can have multiple of those configurations, as you'll see. So it will kind of inspect your current channel structure or current team structure. So they call this thing a team. Cloud Technologies, this URL here, it's kind of a team. And then you have various channels in there. What you can do is basically choose a channel of submission that you want. So either you can send notifications, direct messages, or as something else. So I'll just pop them into notification by default. And you suggest that it should have an incoming webhook integration. So, all right, what do you get? What do you get? You get something like that here, and it's incredibly, well, sorry. Yeah, I should use the copy URL button. It's quite handy actually. So how does it look like if we look at this thing more extensively? You find it's a reasonably ugly and long URL, right? So. Right, the only thing that you basically then need to do is somewhat invoke it, obviously with the right content, the right payload, and you'll be able to produce a notification in Slack. So we save those settings just for you later on in case you work with this. Let me have a look. You can have multiple of those configurations, so you can have multiple webhooks. So if you want to play around with this, do it. Just don't touch other people's configurations, because as far as I know, you can actually, meaning you can actually delete or change or whatever other people's configurations. And it's a bit tedious because they just figured out their own URL, and you're kind of changing or deleting their configuration, which is like, uncool, I guess. So feel free to do it yourself and play around with this. Just make your own configuration in there, and you'll be fine. Cool. All right, so now we have basically this long URL, but looking at it right now, without further exploration at this stage, but we will, what's the possible problem? Anyone? Just need to bring up the API because I don't know that thing by heart. So. Any thoughts there? Well, it's not really explicit, but it actually technically doesn't require authentication. So any request in a required payload format that's sent to that URL actually will do something on your Slack channel. So and this is kind of one approach of dealing with this, is this the whatever you could call it, possibly something like security by obscurity in a way. Basically you have a sufficiently complex URL, you know, based on some hash function that you actually use. So it's not brute forceable-ish, right? So it's hopefully not guessable by anyone else or any other machinery. In this case, you actually don't really need any authentication or the like. What's the possible risk there?
People will send whatever they want into the Slack.
Yep.
Spam.
Yeah, exactly, like spam, or well, the point is, you know, if somebody's monitoring the router for whatever traffic, and it happens that your URL is passing by there as address destination, then it's an easy target for possible, you know, user abuse. Yeah.
Yeah, you also have to trust the people on the job.
Right, good point, yes. So, yep, there's also that element, depending on what you use it for. In this case, it's Slack, yes, you're right. So you have people probably interacting with the system, but it could also be between fully automated systems. So I'm wondering if it's a clever way of linking your, you know, I don't know, payment system in your warehouse using that kind of webhook. You know, I'm not sure it's super secure, especially if it invokes, for example, possible delivery of goods suddenly, just based on a webhook. Again, it's a very generic way of integrating different services. Yeah, but anyway, that's the easiest way of doing it. That's the way it's done in Slack. So just to show that it actually works, because I need to explore it as well. So basically, the simplest way of doing it is actually having a basically a structure that just sends a text content, and let's use our friend Postman for that purpose, which pops up on my main screen. Hang on. So what are the requirements again? Yeah, you can do what you want. I still want to look at this first. Hang on. So we sending in JSON format, and we need to kind of use that URL that we just got, and then we just can paste the content. So they actually have a quite neat specification of what they want from us. So we want to send a request. We don't want to save anything. We just build it from scratch. So, all right. So, I shouldn't have done that. Let's see. First, figure out my webhook again. They have some headers, and they are still saved here from me. So I want to send in JSON format, right? So content type, same thing. You guys saw that, and some content. Let's start with something that is a bit more accessible. Yeah, not that accessible, but it's as simple as sending some sort of. I believe the element was called text. Did I violate any other specification here? Hang on, it's a key, obviously. I need to do that as well. Sweet, so it's a raw one, headers, and that's pretty much it. Let's just send that thing here and see what's happening. So we get back a 200, which is okay. So status code 200 from the request. If we go in here, we have a notification. Yeah, I got that. Goodbye. And there's actually an example here. So actually webhook works. So we just send a plain text to that particular URL. Super straightforward JSON format. So quite easy threshold of getting something into the system. So you can imagine how easy it would be for you to write applications, just to post something on Slack, for example. Obviously, it can be a bit more complicated than that one. Let's see if we find the the full specification for that. Let's see, before we do that, so this is a bit more of an elaborate approach towards the towards sending notifications to Slack channels. So it allows you to send complete attachment, as they call them. So you can attach multiple to one single message. But I think for now we probably should just explore that using a single message. So, and that's where we come to the next point. So right now you saw the basic principles or mechanics of how they actually work. The challenge here was that is fairly transparent, easy to use, which is convenient, but it obviously bears its risks. There are two other methods by which you can actually interact with a system that I want to explore first before I give you a few minutes breaks. And again, the first one is the idea of having just an obscure and long URL, and the payload is kind of safeguarded by HTTPS, but not the endpoint, right? Because it's still specified for the HTTPS request. The second one is some sort of hash-based message authentication code. So basically, you have a shared secret that you use basically to kind of create a digest or a digest of the message that you're currently sending. And only by validating this one on the server side, the actual webhook will be activated, or meaning the trigger may be sent, but it will not be consumed by the client because it doesn't correspond to the secret that was previously shared. So the rough workflow works like this. You have some sort of library, so crypto library. You have the payload. Oh, that's not what I want. The payload, and you use some hash algorithm that you for which you basically create a hash identifier, and then you apply this to the payload, the stringified payload, ideally, and this becomes the signature then, because it includes payload plus secret. And then you attach it as a header, so it would be part of your header request. In addition to, for example, your content type, you would have that signature, and then associated with the actual content. So, and then the receiving party would be able to calculate and compare the signature based on the shared secret that both parties need to have in advance. Yeah, so that's one other way of doing it. So it requires a bit more involvement, at least some sort of prior handshake between both parties. And the third approach is using OAuth. Did anyone deal with OAuth yet, somewhere, somehow? You probably did by, yes, you did, yep. Yep. Yeah, right. So what is it generally used for, just to put in one sentence? Yeah, between? Yes, right. So it's for authentication, but it's also for delegating authentication between services themselves, right? So you probably had the experience that you wanted to make a service, one Google service, accessible for another one, and you need to authorize those services mutually. You do that by using a user authentication in the first place, and then you authorize this use of those services. They exchange a secret token, access token, displayed here pretty much. And from then on, the application is able to access the service autonomously without you further interfering. So it doesn't require repeated authentication per se, but based on your granted access or your initial grant of access, it's possible now that those two services basically autonomously interact. Cool. Sweet. I'll probably give you let's say until 25 past, so it's 17 minutes roughly. No, hang on, that is 12 minutes break roughly, and then we continue. Yep. So.